Let's look at an example. So here, this is my cheesy example from the last clip. We take U1 to be the ones that only have a non-zero coordinate in the first position. And so last time I called it x1 in the first position. I'll just call it t because why not? It's a dummy variable. It doesn't matter. Maybe this reminds you a little bit of like the parameterized form of a line or something like that. Anyway, and so again for u2, we'll take the y-axis. And now we'll throw a third one into the mix. And we'll take this to be the xy plane. Okay, so notice that U1 is a subspace of U2 plus U3. Okay, and so to see that, it's enough to notice that I can write a general element of U1, so something that looks like T0, whoops, 0. I can write this as an element of U3 plus an element of U2, right? So and similarly, just by rearranging this equation, in fact, I could show that U2 is a subspace of U1 plus U3, and U3 is a subspace of U1 plus U2, right? Okay, but let's just focus on the fact that U1 is a subspace of U2 plus U3. So from this, you can see that U1 plus U2 plus U3 is the same thing as U2 plus U3. Since U1 is already a subspace of U2 plus U3, adding it in gives you nothing more, right? So U1 is not really necessary for making that particular vector space. Okay, there's some sort of redundancy going on here. So let's rule this kind of thing out, or at least make a condition stating when it does not occur. So for subspaces U1 through UM of a given fixed vector space V, the sum is direct, or I guess more often we usually say the sum is a direct sum if there's only one way to express an element of that sum as a sum. And in this case, we have a special symbol. We put little circles around the pluses to indicate that everything in that summation is really needed, and if you take something away, then you actually end up with a different vector space as a result. And so if we look at this only one way to express something, look what happens back here where we have two different ways, right? So on the one hand, we can express this as an element directly of U1, just as so forth. On the right-hand side, we can express it as a summation of things from the other components. So there's two different ways to represent that one particular element. And so this whole idea should be a little bit familiar to you. So it should recall the feeling of a notion you talked about in a previous linear algebra class called linear independence. And I'll pose it as a challenge to you to figure out how to phrase this concept of direct sum precisely in terms of linear independence. So pretty soon we'll have some discussion about linear independence in this course, and we might come back to this at that point. But just for yourself, to stretch your understanding and to remember what you know about linear independence from previous courses, figure out how to come up with an equivalent reformulation of this definition in terms of the words linear independence.